Good morning. In this lecture, we also study the if one of event A and B is an impossible event, then A and B are independent as well as mutually exclusive. For example, suppose A equal to empty set, then A intersection being a subset of A and A intersection B is a empty set is equal to empty set, and therefore A and B are mutually exclusive. And also probability of event A intersection B equal to 0 equal to probability of A into probability of B, therefore probability of A equal to 0. That is, we have just note that is A and B are mutually exclusive. And we have give the example of empty set, that is a consider an experiment of tossing three pairs of coins simultaneously. That is, we have uh, tossing three pairs of coins simultaneously, that is ohm equal to that is there are 8 sample space, and number of element in the total sample space is 8, that is n equal to 8, and we get the A equal to getting more than 3 heads. In this total sample space A we have 1 2 the getting more than 3 heads, that is more than 3 heads, that is there is no set the more than 3 heads, that is only we have tossing the 3 coins, and therefore there is no possibility more than 3 heads, that is therefore A equal to empty set, that is there is no favorable event in the sample space, that is here more than 3 heads, that is here A equal to empty set, that is A equal to 0, and therefore probability of A equal to 0. And B is the getting at least 2 tails. Here at least 2 tails is that is this one sample space is 2 THT, TTH and TTT, that is total element in the B is 4, that is n of B equal to 4, and we have getting the probability of event B equal to number of element in the B is 4 divide total number of sample space is 8 equal to 1 by 2, and now A intersection B is equal to empty set, therefore probability of A intersection B equal to 0, that is probability of event A into probability of B. That is, by definition, A and B are mutually exclusive as well as independent event.